Hello, dear friends. Hoping that you are all fine with the blessings of Almighty Allah. And today we will be solving paper 40972, which is the numeric grading system. So starting from 9 highest grade until 1, paper 4 variant 1, and it is May June 2022. Of course, it's not exactly according to the fresh syllabus. There are two questions which are no more with us in the syllabus, so we will not be solving them. By the way, so this is May, June 2022. As usual, time allowed for this paper, it is 1 hour 15 minutes, which means it is equal to 75 minutes. And important thing is the total marks for the paper is 80 minutes. So it means we have less than 1 minute per mark. So while solving paper 4, always we are uh, always trying to finish it at high speed with accuracy. So that is something which is needed. And I will not be using C. It is 2022. So 1 kilogram is with 10 Newton force. Weight is equal to 10 Newton. Or acceleration of free fall, it is 10 meters per second square. But even in this paper, we will not practice with 10 meters per second square. If somewhere we need to use this value of G, so we will be using it 9.8 as it is in action, or it is effective from uh, 2023 onwards. So we will be using G is equal to 9.8, inshallah, in the question solving ahead. So let's start it, and inshallah we will be completing it in this session. And also let me tell you, this paper is comparatively harder. Why it is harder, I can tell you, which if you will check the grade threshold. So that is a grade threshold, that is 37 marks out of 80 for A grade. And on single component like paper 4 or paper 2 or paper 6, when we are seeing component one by one, so maximum grade is A. So 37 marks out of 80, less than even you can say 50% marks were A, because this is a bit tricky paper. And let's see, that's why I have chosen it, so that I can discuss with you the things, and you can benefit it, and you can be ready for your external exams in case if some sort of stuff like this is there in the paper. So let's start. A car of mass M is traveling along a straight horizontal road at constant speed v. Now see, even instead of saying this a straight horizontal road at constant speed v, he was simply is traveling along a road with constant velocity, because speed is constant, road is straight horizontal, which means direction is constant, so velocity is constant anyhow. So at time t is equal to 0, the driver of the car sees an obstruction in the road ahead of the car and applies the brakes. The car does not begin to decelerate exactly at t is equal to 0. So now what is meant by deceleration? And by the way, the definition for deceleration will be same as the definition for acceleration, but there is one difference. Difference is this is a negative acceleration. This is a negative acceleration, and rest we can say it is the rate of change of velocity. So there are 2 marks now. So we have to give 2 valid points. Number 1, we can say that it is the rate of change of velocity. This will give you this will give you 1 mark, and then don't forget to write that it is a negative acceleration. It is a negative acceleration. This will be the 2nd mark. In this way, you can score the 2 marks. Then suggest one reason why the car does not begin to decelerate at t is equal to 0. Even you can check this diagram. So at t is equal to 0, we cannot say that car is with 0 acceleration. It started to decelerate. It started to decelerate. Deceleration starts almost here, decrease in. So why it is not decelerating in the beginning. So this is reaction time error. Mean you will see if you are driving on the road, you see some animal is crossing the road ahead of you and you have to apply the brakes. So there will be a thinking time, reaction time to react, reaction time to apply the brakes. So that's why it does not start at t is equal to 0. So what can I write? We can write that it is due to reaction time to apply the brake, apply the brakes. It is due to human, you can write human reaction time to apply the brakes. Human reaction time to apply the brakes. Now, my dear friends, next is figure 1.1 is the distance time graph for the car from t is equal to 0. So this is a distance time graph. First of all, you have to be very careful. Now state the property. One thing, it is a distance time graph. State the property of distance time graph that corresponds to speed. Distance time graph, slope of this distance time graph, or the gradient of this distance time graph, it gives us what? It gives us speed, because when we will take the gradient, that will be rise over run. So rise is the distance, run is the time. So distance over time is speed. So very simply, this was a straightforward question. So we can say here the gradient of distance time graph. One mark. So this is one valid point. Even you can write the slope. Next, use the figure 1.1 to determine figure 1.1 to determine what? The initial speed of the car. Initial speed of the car. Initial speed in the beginning, and we know in the beginning the speed is constant. So you can choose any point. Okay, easily I can take this point roughly. So my dear friends, initial speed, it means speed that will be equal to gradient. I'm writing g for gradient. That means it is equal to, you can say y2 minus y1 over x2 minus x1, or you can say distance over time. So my dear friends, now starting point here, that is x1. This one value is x2. Here this value is y1, and one box ahead, this is y2. So see, what is this? This y2 is equal to 22. Why 22? As usual, I'm always telling that let's take what is represented by one small division, one small square even. So 1 SS, one small square, is equal to 20 minus 0. In the numerator, the difference between two consecutively marked values like 20 minus 0, 40 minus 20, 60 minus 40, like this. To save time, by the way, even it can be done 60 minus 0, but you have to count a lot of number of squares. It will take a lot of time. So we don't have time in this paper, extra time, or the time to waste. So 20 minus 0 over 10. So it means each box is equal to, each small square is equal to 2 meters, 2 meters. So that's why 20 plus 2, 22. So my dear friends, y2 is 22, y1 is 0, over x2 is 1, x1 is 0, simply as we will calculate. So 22, and answer is 22 meters per second. And answer for this question, that will be in range, not exactly one particular answer. So you can take even before one, even little bit one, after 1 second you can go. So no problem. So answer will be within a range, and our answer right now is 22 meters per second. Then my dear friends, here, when the car is decelerating, there is a constant resistive force on the car due to the brakes. Because brakes are being applied, so there will be a constant resistive force, a force which is opposing the motion. The acceleration of the car is greater than F over m and is not constant. So explain why the deceleration of the car is greater than F over m. So why so? First of all, what is this F over m? From where we are getting this? We know from Newton's second law of motion, F is equal to ma. The resultant force is equal to mass times acceleration. So if I'm making acceleration as the subject of equation, it will become F over m. And deceleration is a type of acceleration. So he's saying actually the deceleration of the car is greater than f over m, mean it is slowing down more quickly as it is mentioned here by f over m. So what can be the reason? Now, the reason is very simple. Only one mark and one particular reason we can give. See, in the question, in the very first line of this part D, when the car is decelerating, there is a constant resistive force F on the car due to brakes. But we know when the car is on the road, there is also air resistance acting. So now to decelerate the car, not only the brakes, but also the air resistance is in action. So that's why it is decelerating at a rate more than f over m, or at a value which is more than f over m. So that's what I'm going to write, that there is air resistance also acting, also acting on the car. It's not only the brakes, but also there is air resistance which is acting on the car. No, the deceleration is not constant. 2 marks. Why deceleration is not constant? As it is decelerating, it means it is slowing down. So air resistance is also decreasing, because air resistance, it depends upon speed of the body. If the speed of the body is more, so the air resistance acting on the body, that will also be the more. And also there is another factor, the surface area exposed to air. But in this case, surface area is constant. This front of the car is constant. So air resistance is changing. Why? Because the speed is changing. More suitable, even you can write air resistance is decreasing as the speed is decreasing, but play more with less chances of right, with less chances of mistake. So say changing. Even if it was increasing, so changing will will do the job for us. Anyhow, so we will say actually what has happened as the car is decelerating, so speed of the car is decreasing, air resistance on the car is decreasing. So resultant force basically on the car is increasing. So we will say speed is changing. So the air resistance is changing, and as a result, resultant force is changing, which is making the acceleration not constant. So that's what I'm going to write. So my dear friends, I will say as the car is slowing down, so air resistance on the car is changing, or even you can say slowing down. So this will give you 1 mark. So the resultant force on the car is not constant. So your acceleration is also not constant. That will be the second mark. So in this way, you will score these 2 marks. Okay, my dear friends, let's move to the next question. That is about the energy, maybe. So figure 2.1 shows water stored in a reservoir behind a hydroelectric dam. So there is the reservoir water height is depth of the water is 150 meter generated to generate electricity. And from here, we will get the electricity. Turbine is there. So hydroelectric power generation system is shown, and turbine is marked, generator is there, depth of the water is also there given. Now, state the form of energy stored in water in the reservoir that is used to generate electricity. So which form of energy is there? Water is at higher level from the turbine. So energy stored in a body due to its height from the ground. So that is gravitational potential energy. So this is straightforward question and answer. So gravitational, and there is no other option than this. Gravitational potential energy. 1 mark. Now, next part. The turbine is 150 meters below the level of the water. Atmospheric pressure is this. The density of water is this. Density of the water is 1000 kilogram per meter cube. So it means this is the density of fresh water. Calculate the total pressure in water at the turbine. So total pressure, very important. What we are going to do when we are talking about total pressure, it means the pressure of the water plus the pressure of the atmosphere, because the air is also exerting pressure on the water. So what I'm going to write, I'm going to write the total pressure, P total is equal to pressure of the liquid plus the pressure of the atmosphere. Pressure of the liquid is rho GH, which means rho for density times G acceleration due to gravity and H is for height, the depth, plus atmospheric pressure. And atmospheric pressure is given, so no need to write any formula for it, just P ATM for atmospheric pressure. Now let's place the values. Density is 1000. Value of G, I'm going to use 9.8 times height, that is equal to 150, plus atmospheric pressure, that is 1.0 times 10 raised to power 5, and the unit here, all together, that will be the pascals. Okay. So now let's solve it out. So my dear friends, the answer is 1470000 plus 1.0 times 10 raised to power 5. So I will just be adding this number. And answer comes to be altogether 157 and then 0000. So we can write it to 1.57 times 10 raised to power 1, 2, 3, 4, 5, 6 pascals. And even you can write, rounding it off, 1.6 times 10 raised to power 6 pascals. That will also work. So total pressure. So total pressure means pressure of the liquid on the body at some depth into the liquid plus the pressure of the atmosphere, because the surface of the liquid is being pushed by the atmosphere. So there is also atmospheric pressure. For we need to consider it when we are calculating the total pressure. Now, the turbine has a cross-sectional area this much. Calculate the force exerted on the turbine by water. Now here students are making a mistake. They are thinking that we have to calculate the pressure of the water only. No, my dear friends. Water is not shielded from the atmosphere. The water stored in the dam, that is not shielded from the atmosphere. It's not protected from the atmosphere. Atmospheric pressure is there. So simply what we are going to do, the formula for pressure is force per unit area. Just cross multiply. We will get force is equal to pressure times area. So pressure 1.57 times 10 raised to power 6 times area, which is given here 3.5. The 1.57 is the numerical value for this pressure we have calculated. So as we are simplifying it, we are getting the answer comes to be 5495 and then 000. So we will round it off. I'm going to write it 5.5 times 1, 2, 3, 4, 5, 6 times 10 raised to power 6 Newton. So that is the answer for this question. So 5.5 times 10 raised to power 6 Newton. Now the water flows through to the turbine through a pipe of constant cross-sectional area, and come here, see the pipe through which the water is flowing to the turbine. This is with constant cross-sectional area. So Explain why the kinetic energy of the water in the pipe remains constant as it flows through the pipe. So again, 2 marks are there. Two valid points we have to give. So what is the equation for kinetic energy? EK, it is equal to 1 over 2 mv square. Now, the density of the water in the pipe, that is constant even in the whole dam, means storage reservoir for water. Density is constant. Volume of this pipe, that is also constant. This implies that, now see, density is equal to mass per unit volume. We need mass to be constant. So if I'm making mass as the subject of equation, so density times volume. So when density is constant, volume is constant. So this implies that mass is also constant. So mass of the water flowing through the pipe is constant. So it means speed is constant. And V is also equal to constant. So kinetic energy of the water flowing through the pipe, that is also what? Constant. So like this, you can answer this part of the question. I'm sure this will be okay. If you will be finding any difficulty, any problem, feel free. You can just in the comment section on the channel, you can ask me. Now, during a picnic on a warm, dry day, a metal can of lemonade is wrapped in damp cloth. Warm, dry day, a metal can of lemonade is wrapped in a damp cloth. Damp means wet. Evaporation cools the water in the cloth. Explain in terms of molecules how evaporation cools the water in the cloth. So very simple formula answer we can give here. Uh, high energy molecules. High energy molecules of water are escaped into the air, are escaped into the air. Escaped mean you can say evaporated, even you can use escaped into the air. Now, the molecules left behind, the left behind have, molecules left behind have low kinetic energy. So, the average kinetic energy is lowered. It means average kinetic energy, we know that is temperature. So it means temperature of water in cloth is lower. So like this, you can give the answer. Next is, as the water in the cloth cools, so does the lemonade. Explain how electrons transfer thermal energy through the metal of the can. Now, metal of the can. So we can say that vibrating atoms, even you can say ions, hit the electron, hit the electrons. This is first mark. Let me tell you, I will be giving you how the marks will be scored. This is the first mark. Vibrating ions hit the electrons. Electrons free are free. Free electrons carry this thermal energy through the metal can and hit the vibrating atoms at the distant end, which was comparatively cold at the distant end, and in this way energy is transferred. So this was the second mark, and this is the third. In this way, you can score all these three marks. So electron, and we don't need to say anything about the convection or radiations here because this is the metal. They said just the metal and free electrons. So initially, the electrons, they gain energy by the vibrating ions, which are hitting the electrons at the hot end, let me say. Then those free electrons will carry this thermal energy through the metal can, and then they will hit the distant electrons. Of course, distant atoms, vibrating atoms, which are at comparatively lower temperature, and the energy will be transferred. So the next question, my dear friends, now, yes, question number 4. It's not in syllabus from 2023 onwards. So we are going to drop this question. Question number 5 now. Figure shows a kitchen tap that supplies the instant boiling water. Kitchen tap which is supplying instant boiling water. So it means some heating system is inside the tap, fitted inside the tap. So cold water passes over an electric immersion heater inside the tap. The boiling point of water is 100 degrees Celsius. State what is meant by boiling point. This is simple. Boiling point, it is the temperature, or you can say fixed temperature, but better simply write it is the temperature. This writing, it is the temperature, is 1 mark, at which a liquid changes to a gas. This is the second mark. Simple. It is the temperature at which a liquid changes to a gas, steam, vapors, whatever. Now, my dear friend, the immersion heater is powered by the main voltage of 230 volts. The tap is opened, the heater switches on, and the current in the heater is 13 ampere. So see, V is given and I is given. Anywhere we need to calculate power, so we can calculate the electrical power, which is product of voltage and current. So P is equal to V into I. So easily we can calculate power and then calculate the thermal energy. Thermal energy is the energy at the move when the heat energy is being transferred. So in simple words, we can say thermal energy produced by the heater in 60 seconds. Time is also given. Calculate the thermal energy. Thermal energy, 2 marks. Very simple. I will write it directly from electrical quantities chapter or topic. Energy is equal to VIT. So V 230, I 13 ampere, T is 60 seconds. And by the way, all the units are system international units. So 230 times 13 times 60, answer is 179400. 179400. So I can round it off. I can write it 1 8 and then 0000. So it means I can write it 1.8 times 10 raised to power 5. 1, 1, 2, 3, 4, 5. And don't forget to write joules, which is capital J. If you are worried about this, how did you get, I got this, I have written this directly, E is equal to VIT, then even I can tell you, we know Power is basically equal to rate of energy transfer. See, if I'm making energy as the subject of equation, so it is power times time. And as I told you, power in electrical circuits, that is V times I times T. So that's what I directly wrote there, VIT. Now, next part is uh, next part is bit tricky and time bit, I mean, you can say complicated. The specific heat capacity of water is 4200 joules per kilogram per degree Celsius. The cold water that enters the tap is at 22 degrees Celsius. So calculate the rate at which water is boiling emerges from the tap. And my dear friends, basically, when it is rate at which water at boiling point emerges out from the tap, it is mass per unit time actually we need to calculate. Now, our all effort will be to calculate this m over t, to make m over t as the subject of equation. Let's start with, let's start with energy E is equal to mc delta t, mcat. Energy is power times time equal to mc delta t. Now, let's manage it in such a way that m over t, t will come in denominator, is equal to power over c delta t. Delta t, please be very careful. Small t is for the time interval, for which the heater is turned on. And capital T is the temperature, and delta T is the change in temperature. Even in the syllabus outlines, it is written Q is equal to mc delta theta. This equation, Q is equal to mc delta theta. The standard symbol for heat energy, thermal energy, is Q, capital Q, is equal to mc delta theta. Delta theta is for the change in temperature in degree Celsius. This delta T is basically in Kelvin. And remember, change in temperature, either it is in degree Celsius or the change in temperature is in Kelvin, they are numerically equal. So that's not making any difference. So for easy to understand, we know energy, very common term for energy symbol is E. So mc delta T, and easily we can memorize it. E is equal to mcat. And you know, mcat is one sort of education, UK based education for the accounts and like this. So easy to memorize. So that's why mostly we teachers are using E is equal to mcat. Anyhow, so now subject of equation is m over t, but still we need to make a change. So I'm writing now m over t is equal to, power is not given to us directly, but we know electrical power is voltage times current over C delta T. Now all the values are with us. See, the voltage is 230 volts, current is 13 ampere over C 4200. Now delta T, this is also, no need to think what is delta T. See, water enters into the tap at 22 degrees Celsius, and then there is some emergent heater inside the tap which is heating the water to boiling point. So what will be the change in temperature, delta T? It will be 100 minus 22. And now we can simplify it and we will get the answer. So when I'm trying and calculating this all, so answer is 230 times 13 over 4200 times 100 minus 22, 9.126 times 10 raised to the power minus 3. Answer is 9.126 times 10 raised to the power minus 3. So no need to write this much long answer. You can simply write 9.1 times 10 raised to the power minus 3. Now what will be the unit? See, m over t, kilogram per second. So it will be kilogram per second. Then, my dear friends, the metal tap is earthed, and there is a fuse in the cable that connects the heater to the mains. Explain how the earth wire protects the user. Now, see, this is the problem. Very few papers are there in IGCSE Physics paper 4, and till 2015 it was paper 3 extended paper. They are never mixing the different blocks. Like now, see, in this question you are observing that block 2 thermal physics and block 4 electricity and magnetism, they are mixed up. So that is making the students also a lot confused during the exam that they need to keep on switching the formulas in their mind, the definitions in their mind. Now we have used already the power, electrical power in the question, and now here the safe use of electricity is also involved here. So that is a bit uh, difficult for a student in a limited time to switch in between the blocks and in between the topics. Anyhow, so the metal cap is earthed, and we have so and there is a fuse in the cable that connects the heater to the mains. Explain how the earth wire protects the user. Protects the user. Now I will say that if the metal cap, I will write these simple words. If the metal cap is becoming live, then all the charge or all the current flows to the earth through earth wire. So that is the use or benefit of this earth wire. Next, explain how the fuse protects the circuit. Yes, it is a weak link. It is connected in series. So when current gets higher than its rating, so the fuse wire melts and it breaks the circuit. That's what I'm going to write. So as the current in the circuit or in the metal cap, you can say, better to say in the circuit gets large, the fuse wire melts and breaks the circuit. Mean breaks the flow of current in the circuit, breaks the circuit. So in this way, we can answer this part. Next, my dear friends. Now, again, there is a question on thermal. Figure 6.1 shows a road next to the sea. On a sunny day, the sun warms the road. Describe how the energy from the sun reaches the earth and warms the road. It is not conduction. From the sun to the earth atmosphere and then to the road, that is basically radiation. We can say infrared radiations from the sun reaches the earth and warms the earth. Then the thermal energy is transferred to the road, and the road gets warm. Road gets warm. Now, next is the temperature of the road is greater than the temperature of the sea. So the surface of the road is black. Suggest one reason why the temperature of the road is greater than that of sea. So see, the road is black. We will say the black color of the road, black color of the road is a good absorber, or even you can say better absorber of radiations, better absorber of radiations. So one mark, that is enough. Then the air above the road is heated by the warm road. Describe how this affects the molecules of the air. Now, very common mistake by the student that the molecules of the air, they expand. They absorb heat and they expand it. Please remember, molecules of the air, molecules of the solids, molecules of the liquids, they never grow bigger on heating and they never get shorter on cooling. So the molecules, they stay the same size. So what is happening? They gain energy, they gain kinetic energy and move faster. So don't think that they gain kinetic energy and move faster will be 2 marks. No, not at all. This is the same thing. Either you can say the molecules of the air gain kinetic energy, or you can say the molecules of the air move faster. And the air expands, or the volume of the air becomes greater. So that's what will be the second mark. Now, my dear friends, I'm going to write the answer. What I'm going to say, molecules of air gain kinetic energy and the volume of air is increased. That's what is the correct answer. See how we can mark it. See, gain kinetic energy, 1 mark, and this one is another mark. Like this, we can say. Then, my dear friends, the next is a cyclist traveling along the road notices that a cool breeze is blowing from the sea to the land. Explain how convection produces this breeze. Convection. This you may include a diagram if it helps your answer, but this is very simple. Without diagram, we can write, and 3 valid points we can give to get these 3 marks. But convection, first of all, convection is a phenomena that is taking place through fluids, mean liquids and gases. Now here, the story is liquid, which is into the sea, mean water, and the air, which is on the beach, or of course on the road, above the surface of the road. And convection, of course, conduction, convection, and radiation, all these three modes of transfer of thermal energy, they need the difference of temperature for the thermal energy to flow from one body to the other body, from one place to the other place. But they have different mechanisms. Like convection is caused by the difference in density. Hot air, it rises up because it is less dense. And cool air, it sinks down because it is more dense. So this will be the key concept which we will be writing to score these 3 marks. Now, my dear friends, what I'm going to say, see, a cyclist along the road notices that the cool breeze is blowing from the sea to the land. Explain how convection produces this breeze. You may include a diagram if it helps your answer. We will say the air above the road gets hot. It becomes less dense and rises up. And rises up. Then the air above the surface of water is cold and more dense. This dense air or this cool air flows from sea to the road. Like this, you can say, and you will score the 3 marks. Okay, my dear friends, let's continue. Next is now, yes, paper. Now, question number 7. That's of course on physics of waves. Figure 7.1 is a full-scale diagram of a small nail N, you can see, in front of a thin converging lens. The line L represents the lens. You can see there is a vertical line, double head arrow vertical line uh, from the top to the bottom of the grid, and that is labeled L, and this is the position of the lens, and basically this is the central vertical line of the lens. Then figure is full scale. The focal length of the lens is 3 centimeters. And what is the focal length? Focal length is the distance from the center of the lens to the principal focus, to the focal point, or it is the distance from the principal focus to the center of the lens. Now here, principal focus is not marked. First of all, rays of light parallel to XY are traveling towards the lens. Describe what happens to the light after it passes through the lens. Now, we will say rays of light after refracting from lens converge at one point called principal focus. Okay. Then called principal focus, and after passing through principal focus, these rays are diverge. Now, this point will be difficult for a student to write or understand. I will explain it. Just a minute. Rays are diverged. So what is this all story which I have written? See, let's suppose these are the parallel rays of light. Like this is one going here. This is another one. And let this be the focus. This way. And this one will be passing like this. Now see parallel rays. First of all, they refract here. That's what I wrote. This is also refracting over here. Then they converge at one point. That is the focus. And after passing through the focus, see, they are diverging. Diverging means they are spreading apart again. So that's, now see, now let's read whatever I have written. First of all, they said parallel rays to XY. XY is the principal axis. So the rays of light, after refracting from the lens, they are refracting in changing direction from here, this point and this point. From the converged lens, refracting from lens converge. They converge or focus at one point called principal focus, this point. And after passing through the principal focus, these rays are diverged. You can check they are going now further apart from each other. They are diverged. That's what I have written there for these 3 marks. Now, just it was for the sake of explanation. Let's move forward what they are asking. Now, my dear friends, next is on figure 7.1. On figure 7.1, mark and label with F each of the two principal focuses of the lens. Now, see, the focal length of the lens is 3 centimeter. 3 centimeter. And what is focal length? It is the distance from the center of the lens, which is this one, from the center of the lens to either side, on both sides, from the center of the lens to the principal focus. So it means focus is at a distance of 3 centimeter. Now, the most common mistake done by the student, they are just picking up the ruler and trying to mark 3 centimeters on this graph. That will not work, my dear friends. They are giving you, they have given you, by the way, see, 1 centimeter is equal to how many boxes? See, 1, 2, 3, 4, 5. So for 3 centimeter, it means 3 centimeter will be equal to 3 times 5 small squares. So 15 small squares. And here especially, I cannot use the ruler because I have zoomed it in. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it means one focus here. So 5 plus 5, 10 plus 5, 15. Another focus here. So I have marked the focus, but by counting 15 boxes from the center of the lens on both sides. 15 small squares. Then next is the small nail N of height 1.2 centimeter is positioned 2 centimeter to the left of the lens. 2 centimeters to the left of the lens. Okay. By drawing on figure 7.1, find the position of the image I of N, add image to the diagram. So now 3 marks. And this image is definitely virtual because this is the case which we are using for magnifying glass because the object is placed within the focal length. In other words, object is between the focus and the lens. So image will be not real, it will be virtual. And it is the case which is used in magnifying glass. And this is the only case, my dear friends, which is in case of convex lens, which is producing virtual image or imaginary image. So we will go this way first. Then this line or this ray will pass through the principal focus, and as the image is going to be virtual, so extend it to save your time in exam, even when you are drawing the direct lines. Okay, so this is done. Next, second ray has to pass from the center of the lens. So this will be passing through the center of the lens like this. And also let's redraw it the backward direction like this. And we need to stretch it also. So roughly they have intersected over here. But don't forget to put the arrows here, here. Better even to give the arrows so that you can give the direction. Now they have asked us, they have told us to draw the image, add the image I to the diagram. So not only we will show the intersecting point, but also the image will be shown. And image is always directed from principal axis towards the point of intersection. So arrow will be upward and the image I we will mark it as like, we will mark it like this. We have scored the 3 marks. Then still explain whether I is real or virtual. I have told you already within the explanation. Image I is virtual because it can not be drawn on the screen. Drawn on the screen. Or in other words, whatever you have observed, you can write the rays of light, they did not really intersect. That's why it is virtual image. State the name given to the lens. State the name given to the lens when it is used in this way. I told you already, this is the case which is used in magnifying glass because image is really big as compared to the object. So you can write here magnifying glass. So this was, by the way, a formula question, normal question, not very tricky. Then next, figure 8.1 shows two vertical cylindrical tubes and a cylindrical magnet held in vacuum. So this is all is in vacuum. This is all in vacuum. One tube is made up of plastic and other is made up of copper. In other words, one is insulator, another one is conductor. The two cylindrical tubes have the identical dimensions. What does it mean, identical dimensions? It means volume of both tubes, length, width, thickness, each and everything is same. Volume, length, width, thickness, everything is same. The magnetic field of the small cylindrical magnet is very strong. Mean the magnetic field of this magnet, it's very strong. Then initially the magnet is at rest. If it is at rest, so its initial velocity is 0 at the top of the plastic tube. So he is placing the magnet at rest first at the top of the plastic tube. The magnet is released and it falls through the plastic tube without experiencing resistive force. So no air resistance because it is in vacuum. The magnet takes 0.67 seconds to fall to the lower end of the plastic tube. Now the mass of the magnet is 0.1012 kilogram. Calculate the kinetic energy of the magnet when it reaches the lower end of the plastic tube. Now see, question is about magnets and he's asking kinetic energy. So this switching between blocks or between topics also, as I told you in the beginning, is bit tricky, difficult for the students in a short span of time to switch quickly and do it correctly. So we need kinetic energy. Okay, no problem. We will try to calculate it. So kinetic energy equation is, my dear friends, EK or KE is equal to 1 over 2 mv square. So 1 over 2, mass is given 0.012. See, this is the mass, this is the time, and initial velocity is 0 at rest. So now final velocity we don't have. How to get the kinetic energy? So first we need to calculate the final velocity. How to get it? Now see, we have actually initial velocity, we have the time, and even we have A, which is equal to G, that is equal to 9.8 meters per second square. Now you may think, sir, how? Actually, see, it is released and it is falling through the pipe as the plastic tube and this magnet are in vacuum. So there is no opposing force or resistive force. This experiment is being conducted in vacuum place. So acceleration due to gravity will be equal to acceleration. So we need V. Which equation will help us out now? See, we know acceleration is equal to V minus U over T. This will work. V minus U times 1 is equal to V minus U, A times T, AT. T is equal to U plus AT. Now we can do it. U is 0. A is equal to G, which is 9.8. T is 0.67. So, my dear friends, 9.8 times 0.67, 6.566. So what is the speed? Final speed 6.566. So we can write 6.6 meters per second. Now we can do it. So just place this value 6.6 here. And as we will simplify, 6.56 square is equal to this times 0.012 equal to this times 1 over 2. Answer is 0.2586. 0.2586. So not this much four significant figures. I will be simply rounding it off to 0.26 and energy. So it should be in joules. Okay. Now the magnet is then held at the top of the copper tube. Before it was on the plastic tube, now on the top of the copper tube and released. As it falls through the copper tube, an electric current is generated in the copper wire. So explain why there is a current in the copper wire. So this is simply because of the electromagnetic induction. As the copper wire is passing, as the strong magnet is passing through the copper tube, so there is a relative motion between the copper tube and magnet. So in other words, the magnetic field lines are being cut by the copper. And EMF is induced due to electromagnetic induction. That's why there is current. So very simply, we can say that magnetic field lines are cut by copper. So an EMF. And EMF is induced due to electromagnetic induction. One mark here and one mark here. Then, my dear friends, the current in the copper, see, it is mentioned very clear. The current in the copper produces a magnetic field of its own in the tube. So the magnet falls much more slowly in copper tube than in the plastic tube. Explain why the magnet falls more slowly in the copper tube. See, more slowly in copper tube. That is just because of this magnetic field of current. Let me tell you roughly, if you remember your two lessons. Let's suppose this is a copper tube. I'm just considering it, and this is a copper tube. And there is current induced in this copper tube. If current is induced, so there will be magnetic field also. Let's suppose this side of the copper tube is having north and this side is having what? South pole. It is mentioned that the current in the copper produces the magnetic field of its own. Now, when that cylindrical magnet is placed to be dropped through it, this cylindrical magnet is placed here. If here this north and south, I'm not going to write it first. Wait a minute, they will come later. So let me say, if this end of this magnet is north and this end is south, so this current will induce the poles, magnetic poles, in such a way here will be north and here will be south. Why? Because this induced current, it always opposes the change which is producing it. So if the magnet is falling downward through this pipe, so there will be the magnetic field of the induced current opposing the motion of this magnet. So that's why it is moving slowly as compared to the plastic tube, because in plastic tube there is no current induced, as that is an insulator. So if there is no current induced, so there will be no magnetic field of the current. There will be only the magnet of this cylindrical magnet. So my dear friends, what I'm going to write here, the answer, now see, there is an opposing upward force. Opposing upward force. And that's why it is falling down slowly. So There is an opposing upward force on on cylindrical magnet, which is 1 mark. And then we can say the induced current always opposes the change producing it. If you don't remember, just say it is because of Lenz's law. Always opposes the change producing it. So like this, you will score the second mark, my dear friends. Then next question number 9. Again, this digital and analog signal is with us, but these logic gates are not with us. So digital and analog signal, they are in the physics of waves. I can give you the definition of this one. Digital signal, that signal has discrete set of values. Discrete set of values the signal has discrete set of values, like it is only two states, 0 and 1, while analog signal has continuous continuously varying signals or values. Continuous signals or values. Now, like this, see, this is 0, this is 1, 0, 1, 0, 1, 0. This is digital signal. This one, no, mean, uh, no pattern, nothing, continuous value. So this is analog. This is analog signal. Analog signal. So continuous variation. One example I will give you, that let's suppose you are in a medical college, in a university, engineering university or college or engineering college. So there is a class of 30 students in your badge, like that, your section having 30 students. So if we talk about the ages of the students, so continuous values are there. Maybe some are 18 years old, some are 19 years old, some are and many are in between 18 and 19, like this 17 to 19. If 30 students, there might be 13 different values of the ages or your masses or your heights. So the masses of the students in a class, analog values. Heights of the students in a class, analog values. Uh, Ages of the students in a class, analog values. Many numbers can be there. May like if there are 30 students, there may be 30 different values. So that is analog concept. But in the same class, if you talk about the gender of the students, boys or girls, only two states are there. So when there are only two discrete values, so that is digital. So in this way, you can remember it. Now, my dear friends, these logic gates are no more with us, not in syllabus from 2023 onwards. There. Next is now question number 10. And in this paper, of course, there is no space physics. That is included from 2023 onward. I'm talking about the space physics. Now, two isotopes of hydrogen are 1H2 and hydrogen 1H3. State one similarity in the composition of their nuclei. Very simple. Similarity is same number of protons, because the definition of an isotope is atoms of the same element with a different number of neutrons but same number of protons. So similarity, number of protons. Describe how a nucleus of hydrogen 3 differs from a nucleus of hydrogen 2. So we can say 1H3 has one more neutron. That is the difference. One neutron than 1H2. So 1H3 is heavy than 1H2. So in this way, you will score 2 marks. How? Check. Uh, Writing up to here, this will give you 1 mark, and then this is the second mark. Even you can say 1H3 has one more neutron than 1H2. So 1H3 is unstable as compared to 1H2. So stability also, as the number of neutrons are increasing in the nucleus of an element, the stability of that nucleus is decreasing. So it means decreasing unstable. So it means 1H3 is more unstable than 1H2. That can also be written. Now in a nuclear fusion reactor, a nucleus of hydrogen 2 fuses with a nucleus of hydrogen 3 at an extremely high temperature. This fusion reaction produces, isotopes of element X and releases a neutron. Explain why an extremely high temperature is needed when forcing these two nuclei together. So, see, nuclei of not only hydrogen but for any element, atom nucleus is positively charged because there are protons and neutrons. Neutrons have no charge, proton has positive charge. So nuclei of hydrogen, which we are trying to fuse, they have positive charges. So there is a strong repulsive force. So to overcome this repulsive force, very high kinetic energy is given. In other words, temperature is needed so that they can fuse together. That's what I'm going to write for 3 marks. Hydrogen nuclei has positive charges. This is the first mark. So there is a repulsive there is repulsive force between these nuclei. There is repulsive force between these nuclei. So to overcome this repulsive force, very high temperature, high temperature means high kinetic energy is needed. Now, my dear friends, see positive charge 1 mark, repulsive force between these nuclei, that is the second mark, and then this is the third mark. Using nuclide notation, complete the equation for this reaction. See, the fusion reaction produces an isotope of element X and a neutron. So I can write here X and also the neutron. Neutron symbol is 0 and 1. So see 1 plus 1, 2 here. Proton number, and 2 plus 3, 5 is the nuclear number. So it means here it should be 4. Such that nuclear number is 5. So here 4 plus 1, 5. So 2 is the proton number. So here 2. So 2 plus 0 is equal to 2. You can write this way. Or even not necessarily that you have to use this exactly X. In exam, of course, you can even write 2He4 plus 0 and 1. So here same. And this can be written. And now see even here. So 2 plus 3, 5. So here 4 plus 1, 5. And then 1 plus 1, 2. So here 2 plus 0, 2. So equation is law of conservation of charge is there, and law of conservation of mass is also there. It is applicable. So the equation is correct. So this was the paper, my dear friends. Hope you have understood it. And in case of any questions or doubts or ambiguity, you can ask me in to the channel comment section. You can ask me, and even any other paper or any question from paper 2, 4, 6 of IGCSE physics. You have any doubt, please share with me. I will be recording it and then placing it on the channel. And if you have understood it and it is useful for you, to do subscribe my channel, share it with your friends and family. Stay blessed. Take care. Bye.